All right. So in 7.1, or chapter 7 is all about substitution and elimination reactions. And so what we're going to do to talk about substitution and eliminations is to start with a new type of functional group called alkyl halides. And these functional groups are characterized by having some alkyl group, like this ethyl group in black, bonded to some halide group that we represent with an X, typically fluorine, chlorine, bromine, or iodide. And they're useful in a couple ways. The couple ways that are what the chapter is named for, and that is specifically substitution reactions, as shown here, where some nucleophile reacts with the alkyl halide, displacing the halide group to make a carbon nucleophile bond, and displacing the X minus. The other type of reaction that we often talk about are elimination reactions. And in these, you have some hydrogen that is somewhat acidic, and you have a base that's able to deprotonate that hydrogen, make a double bond, and again, eliminate the bromide, forming a pi bond. Please notice in this case that the base abstracts a proton from the substrate. And the problem is that there's competition between these two types of reactions. It's not so simple as saying we would like to run substitution or we would like to run elimination. Often they're happening both at the same time, and it's kind of difficult to control under the best circumstances, unless you're smart organic chemists like we are. Like, let's say, for instance, you wanted to run this type of reaction, where you had 2-chloropropanol and you react that with sodium hydroxide. What you will get upon finishing your reaction is 2-propanol plus the sodium chloride and the double bond product, the 2-propene. 2-isopropanol and 2-propene both represent the products of substitution and elimination. So what we want to do is understand why you get both products. And the reason why is because the sodium hydroxide, the hydroxide anion, is both basic and nucleophilic. And so whenever we are thinking about why else these reactions happen, we need to understand why it is that both reactions can occur with alkyl halides, because it's not all about the nucleophile or the base here. Sometimes it has to do just with the functional group themselves, which is the alkyl halide. And the reason why alkyl halides are able to do these types of reactions is that they have a large dipole between the halide and the alkyl group, meaning that the carbon there is partially positive and can react with nucleophiles. Also, the halide group can be a good leaving group, which means that it's amenable to elimination reactions because it would be just as happy on its own. And the reason why it's so happy on its own is because it's a stable conjugate base due to the fact that HCl, HBr, and HI are all strong acids. So in general, good leaving groups are conjugate bases of acids with pKa's less than 0, like HCl, HBr, and HI. And we'll learn more about the substitution and elimination reactions as we go on in Chapter 7. So this is your first lesson, and I look forward to many more.